All right, so Unit 2 is about matter and energy, and the first part of Unit 2, we're going to cover these, learning objectives. Distinguishing between mixtures and pure substances and classifying pure substances as either elements or compounds. Identifying the symbols and names of common elements. We're going to identify the 3 states of matter and describe their properties. Distinguish between chemical and physical properties of matter, and differentiate between chemical and physical changes. And we're going to briefly take a look at a chemical change as a chemical reaction. So, first learning objective, distinguish between mixtures and pure substances and classify pure substances as elements or compounds. So every sample of matter is either a pure substance or a mixture. So we already know that matter is what makes up everything, and it has mass and occupies space. So I want to say we briefly talked about this in Unit 1, where we looked at matter, and it's either going to be pure substances or mixtures. And we're going to take a look at first at elements, which can either be molecules or atoms, and compounds, which are going to be ionic or molecular. We will talk more about compounds in Unit 4, but what do you think are the forms of matter that we encounter most in our daily lives? Do you think that it's going to be pure substances or mixtures? What do you guys think? Yeah, mixtures. For the most part, we are encountering mixtures in our daily lives. So, pure substances. We can either have elements or compounds. And when we consider elements, we're going to take a look at some elements that actually, they actually come in molecule form. And so copper, so in chemistry, we use a lot of models to help describe these things that we can't see, right? So most of chemistry is this abstract thought, and we have to use something to help us visualize the things that we can't see. So our models are generally made up based on what we've already learned about matter. So like I said before, I really want you to understand that you already know chemistry. You already know a lot of chemistry. You do chemistry every day if you cook. And I just want to show you that you know it, and it's not as difficult as it may seem. So if we take a look here, copper, these round spheres, they each represent one atom of copper. And notice that here, the atoms are tightly packed together because this penny is actually a solid, right? Sometimes elements can be atoms that are joined together chemically, such as oxygen. And we're going to take a look at a little schematic so that you guys can visualize these things. Compounds are going to contain 2 or more elements chemically combined. Notice that I said oxygen. Notice that I said that oxygen is 2 of the same atoms joined together, so it's still a pure element. Whereas compounds are generally made up of 2 or more elements that are chemically combined. So here we have a representation of water where we have red and white spheres. Which one, this is called a space filling model. Which one of these are the oxygen and which is the hydrogen? What's the red ones? The red ones are going to be what?
Oxygen.
Yes, the red ones are oxygen and the white ones are going to be
Hydrogen.
Hydrogen. All right. So here we have aluminum, and aluminum cans. Notice that we have all these aluminum atoms together and they're nicely and tightly packed. Okay, so those are pure substances. And pure substances that contain one type of atom. Here are some examples. And the physical properties of elements are that they cannot be separated into simpler substances by chemical means, right? Um, so far, well, this 118 is kind of outdated. We've got, I think, 121 elements that have been identified. 91 of them occur naturally on Earth, and some of them have been created by scientists. If you've ever taken if you've ever had to do a scan or something like that, and you ever had to do a scan, they inject you with something called technetium 99M, and it is a radioactive, element that is used to help to give contrast in some like CT scans and that sort of thing. So compounds are, they're made up of two or more elements in a definite ratio, such as the following. Hydrogen peroxide is H2O2, sodium chloride is table salt, which is NaCl, glucose, which is our major, well, no, I'll take that back. Glucose is our energy currency. Our bodies live off glucose and our cells need glucose in order to function. It has 12 carbons, 22 hydrogens, and 11 oxygen atoms in 1 unit of glucose, or 1 molecule. Water is H2O, and the only way that compounds can be separated into their pure elements is by chemical means. So here we have a representation of peroxide where we've got 2 oxygens and 2 hydrogens. Why do you think that the oxygens are larger than the hydrogens? Anybody want to take a stab at it?
This is the thinking.
Yeah, the oxygens are actually larger. It has a larger atomic number, so that means it's got more protons, and so it is going to be a larger atom, right? It has a higher atomic number. Good guys, good job. All right, so can you guys think of some other compounds? I was actually going to give you a hint. It's something that maybe we might not all love it, but a lot of people like it. It's their favorite. I won't say favorite either. Why or how can they only be separated by? No, they can only be separated into their pure elements by chemical means. Well, NaCl, everyone knows NaCl, but what about ethanol? What's ethanol?
No, it's not called.
It's alcohol, yeah. You know what? You are actually right. Glucose should be C12. Yeah, it should be O6. I need to fix this slide. You caught that. Sometimes I don't catch certain things, but you guys are good. Yeah, I'll fix this. Glucose is C6, H12, O6. Yeah. I think this is supposed to be sucrose. Yeah, you are smart, Aziz. Yeah, that's sucrose. This is actually the formula for sucrose, not glucose. Yes, glucose plus fructose gives us sucrose. All right, so those are some chemicals that you already know. So what are mixtures? Mixtures are combinations of 2 or more pure substances, and each substance is going to retain their identity. They're not chemically joined together. They can be in different proportions, and these can actually be separated by physical means. So a homogeneous mixture, like a Coca-Cola, has the same composition throughout. Brass is also another homogeneous mixture that has the same composition throughout. Whereas a heterogeneous mixture is not uniform throughout. So let's say we have iron filings and sand, or a glass of water that's got pennies down at the bottom. What are some ways that you can separate a mixture? One of them is shown here in this diagram. What is this diagram showing? Yeah, filtration is a way to separate a mixture. How would you separate the iron filings from the sand? What could you use to separate the iron filings from a sand?
Magnet.
Yeah, you could use a magnet. You could use a magnet, right? So mixtures can be separated by physical means, right? Because if I just put a magnet over this set of this iron filings and sand, you will see the iron filings kind of jump up to the magnet. All right. So, classification of matter. We have pure substances and mixtures. Pure substances are going to be elements, which are made up of all the same atoms, or compounds, which are individual units composed of more than one element type. Mixtures can either be homogeneous or heterogeneous. When they're homogeneous, you see the same composition throughout. Notice that this brass and copper, the copper, it's copper, zinc, copper. Notice that it's uniform throughout the entire mixture. Or a heterogeneous mixture where we've got something like water and pennies. I am going to share my screen, and I want to show you a representation here. Can everyone see these little things floating around on your screen?
Yes.
Yes.
Okay. So let's take a look. This thing is in my way. Let's take a look. Okay, go there. All right. So this is let's go back to the first page. What is air, right? And air is composed of atoms and molecules. And if I let's get rid of everything. So what are the atoms that are found in air? We've got krypton, we've got xenon, we've got some neon, and we've got helium. What are the molecules that are found in air? We've got nitrogen. So remember I said that some elements are made up of more than one atom chemically joined together. Notice that nitrogen is two atoms of nitrogen chemically joined together, and that is how it's found in its elemental form. Oxygen is also the same, where it has two atoms of oxygen chemically joined together. Hydrogen is another one of these. What is a word that you think you can use to describe these atoms that have two? Think of a word that you can come up with the word atom and another little word that you can describe these molecules that are made up of two atoms. Anybody know? Anybody have an idea of what we call these? Ah, yes, diatomic. Di is the little word for two, right? And atomic, diatomic, two atoms, right? So these are diatomic molecules, and there are 7 of them that you should memorize from the periodic table. They actually make a 7 on the periodic table. Let me see if I can think of them right quick now. Nitrogen, oxygen, hydrogen, No, I can't think of them right now. And you see, I don't have them memorized, but when you look at the periodic table, it makes a 7 on the right side. I should know them. See, you guys have had chemistry before. I couldn't think of so hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, and fluorine. Yes, high school memories. Good. So you've learned this. So notice that air is made up of a mixture, and what we didn't look at is water. Notice carbon dioxide is made up of a carbon and 2 oxygens, and we've got methane, which is carbon and 4 oxygens. Let's do a couple of these challenge me questions. The largest component of air is nitrogen gas. Is that an atom, compound, or molecule? What do you guys say?
Molecule.
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 Yes. All right. What is the difference between a compound and a molecule? What's the difference? Is there a difference between a compound and a molecule? There is a difference. No, so it doesn't have anything to do with there being what was that statement I wanted to address?
Naturally occurring.
Yeah, it doesn't have anything to do with it naturally occurring. Molecules are made up of nonmetals, and compounds are any combination of different atoms chemically joined together. So molecules are a specific type of compound that are made up of nonmetals. Table salt, otherwise known as NaCl, is composed of sodium and chlorine. Is it an atom, compound, or molecule? What do we got?
Atom, compound. Compound.
It is a compound. Yes. And which classification of matter could be separated using a filter? An element, a mixture, or a compound?
Mixture.
Mixture. Yes. So, okay, let's get back to the PowerPoint. Oh, wait, I've got to stop this share. Hold on, guys. All right. Okay. So if you wanted to determine if you have a sample of matter and you wanted to determine what it was, you would use a schematic something like this. Are the properties and the composition constant? If no, then we've got a mixture. If yes, we've got a pure substance, right? So those are physical and chemical properties. If we have a mixture, is the mixture uniform? If the answer is yes, you would say it's homogeneous. If no, it's heterogeneous, okay? If we have a pure substance, is the separation by chemical reaction into simpler substances possible? The answer is yes, you have a compound. If the answer is no, you have an element. Okay? All right. Let's move on.